Yes, we're keep on moving to 7.2, which is permutation and the fundamental counting principle. Our objective today, scholars, is that students will be able to use the fundamental counting principle to find the probability of given situations. Because many probability problems involve counting the numbers of outcome to an experiment and event, it is important to develop techniques that will allow us to count the outcomes in sample spaces that are very large, because we won't want to do like what we did with the tree diagram and then count all different possibilities. This tool that we're going to talk about today is called a fundamental counting principle and will be illustrated below. Exercise 1. Consider flipping a standard coin and rolling a six-sided dice. When we flip a coin, we know there are two possibilities. It's either heads or tail. And then on a standard die, we know it's either 1, 2, 3, 4, 5, or 6. Draw a tree diagram to determine the total number of outcomes for this experiment. So you're flipping a coin. So my first coin is going to have a head or it's going to have a tail. And then I want to roll the dice. So here I'm going to have 6 choices. So it's going to be 1, 2, 3, 4, 5, 6. And here I'm going to have 1, 2, 3, 4, 5, 6. Because I'm rolling a coin, heads or tail. And then from this one, I'm either doing rolling the dice, which has 6 choices. It says, how could you determine a total number of outcome by considering the outcome just from the coin and the die? So if I was to look at this, I would see there's 1, this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 possible outcomes, but how can I look at these numbers? Here there are 2 outcomes, and here there are 6 outcomes. What can I do with these numbers to give me this total number without having to go and do this? So the shortcut, which is the fundamental counting principle, states that the number is actually 2 times 6, which is 12, which is what I got up there. 2 is my first possibility of a standard coin, and 6 is the possibility on the coin. Now, take advantage of this counting principle in the subsets that are often easier to count in the overall complex situation. So you would want to use this counting principle and make it a lot easier when you're dealing with big numbers. So it says the exercise 2. At a cafeteria, a student can order the daily special for $4.99, considering 1 drink, 1 salad, and 1 entree. So that's what she can get. 1 drink, 1 salad, and 1 entree. Now, pay attention. It says there are 5 drinks to choose from, 4 salads, and 3 entree. How many different ways can this person do this? So number has to equal how many drinks. So it has to be the number of, let's call this the drinks, times the salad, times the entree. So the drinks, if you want to write it out, it's fine. They're 5 drinks times 4 salad times 3 entree. 5 times 4 is 20. 20 times 3 is 60. So she has 60 different ways of making her special for $4.99. Same thing that goes with 3. The letters are to be chosen from the word hyperbola without replacement, and that's a key part. Without replacement to create a 4-letter word code. Determine a number of 4-letter code that begins with the vowel Y here. Here, Y is a vowel. So, again, determine a number of these 4-letter codes that begin with 2 vowels. So Y is a vowel. Now, first of all, you want to look at is how many choices? Hyperbola. la. So I have to break this down. So there we have vowels and consonants. So how many vowels do we have? It says Y is a vowel here. So I know my vowels are going to be Y, E, O, A. Am I missing any? No. So there are 4 vowels. And then my consonant will be 1, 2, 3, 4, 5. But it says, know what it says? We want to create a 4-letter code. Determine these 4-letter code, but it has to begin with a vowel. So think of I'm making a code 1, 2, 3, 4. This has to be a vowel. This has to be a vowel. This can be anything. So now my vowels, what are my choices? So my vowel, there are 4 vowels times 3. Remember, it says without replacement. So if there are 4 vowels, I choose one for the first one. So that means I have 3 left. So the total here, there are 9 letters in total. I already used 2 letters because it says without replacement. I already used 2 letters, so that means there are 7 letters left. So these 2 that can be anything would be a 7. So I use 1 more, take away 1, then I have 6 left. So this would be my 4-letter code. 4 times 3 times 7 times 6. So how many number of 4-letter code I can make? That's 504. That's my final answer. Okay? Now let's move along. It says here, a special application. Here we go. A special application onto the counting principle is something that we're going to call permutation. So permutation has to do with, it's the order of object, and this is extremely important, ordering of objects without replacement. So permutation has to do with without replacement. So it says, consider the word CAT, 2-letter codes that are made out of this letter without replacement. So I want to have CAT. I want to have what 2-letter codes I can make. So I can make CA, I can do CT, I can do AC or AT, then I can do TA and TC. Now it says calculate the number of codes. So remember what I said, the number of code. Think of it as you're making one here, 1 letter, 2 letters. So the first one I'm going to have CAT has 3 letters, and then there's 2 more. CAT, 3 letters, but it says without replacement. So if I pick a letter here, right, I'm not going to use that letter again, so there are going to be 2 choices left. So the total possibility would be N is equal to 6. Now, permutation are often used to count on their own. So really quick, think of this. Permutation is a little formula that we need to know. So it says permutation notation, a number of ways to permutate n objects taken r at a time is noted as NPR, which is the same thing. If I was to calculate this, it would be n factorial, this is what you're writing, over n minus r factorial. This little exclamation mark means factorial. So again, that's n factorial, just in case you can't see this. This is what you write, n factorial over n minus r factorial. So this is why we're going to calculate this by hand. Now, I put some screenshots here for you to see. So when you go to TI Inspire Calculator, you're going to go to Menu. You're going to see this pop up here. You're going to go to Probability. And then you're going to choose, see, notice it says factorial, which is my little exclamation mark. You're going to choose permutation. So let's say I want to do something that says 3p2, which is what we had up here. We're going to enter it like this. So this is actually the permutation for what we just did. There are 3 letters, C-A-T, and I want to choose 2 letters to make a 2-letter code. So this is going to be enter as 3, 2. It's always the N, which is your first number. Now I want you to practice, write out the following permutation. What's your N? And I want you to write this out as permutation. Remember, it's n factorial, which is 8 factorial over 8 minus 3 factorial. And then you should do this on the calculator. You get 336. So remember, on the calculator here, when you go here, you will enter 8, 3. What about B? Try doing B. 15 factorial over 15 minus 2 factorial, which will give us 210. Here is 4 factorial over 4 minus 4 factorial, which is 24. So just to point out, when you see the word factorial, and maybe you want to write this down, if I have something as, I don't know, 4 factorial, that means 4 times 3 times 2 times 1. Factorial just means you start at that number and you multiply all the way down to 1. I don't know, if I had 120 factorials, I will start 120 times 119 times 118 all the way down to 3 times 2 times 1. This is the same thing as saying 8 factorial would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 8 minus 3 would be 5 factorial, which will be, let me just take this out so you can just see what I want you guys to see. So this is 5 times 4 times 3 times 2 times 1, which the 5 is the 4, the 3 is the 2, and the 1 cancel out. 8 times 7 times 3 is the same thing as 336. So this goes into what we were saying whenever, and I'm going to take this off for a second, whenever you see something that looks like this, it says 8p3, it means you're starting at 8, but you're only choosing 3, you're making 3 choices. So that's how we ended up with that 8 times 7 times 6, which will give us the same 36. So for this one, I could have just done 15 times 14. I'm only going 2 spaces. Here, I can do 4 times 3 times 2 times 1, because I'm doing 4 choices. Now let's look at our last example, which is exercise 6 for today. It says 10 runners are entered into a 100-yard dash. How many different ways could the runner finish first, second, and third? Express your answer in permutation notation and as an integer. So there are how many runners? 10 runners, and it's permutation. First, second, third, so that's 3 choices. So this means 10 times 9 times 8. Remember, this is the same thing as 10 factorial over 10 minus 3 factorial. All of this will give you 720 as your final answer. Okay, so remember guys, factorial, what this means, how do we get this on the calculator? And then we want to go into permutation. Very, very important. Permutation means without replacement. That's super, super important. So a really short video for today. Now go ahead, do your practice problems, and I'll see you for mastery. Good luck!